Welcome to another deep dive on G Fun Facts Online. Today, we are exploring a breakthrough that sounds like science fiction, but is actually happening right now in the laboratories of King's College London. We are talking about the end of the dental drill and the beginning of a new era where we heal teeth instead of just patching them. And the secret ingredient? It is not a rare metal or a high-tech synthetic plastic. It is human hair. Let's get into it. To understand why this is such a massive paradigm shift, we first need to look at the biological tragedy of your teeth. Dental decay is effectively a silent pandemic. It is one of the most common chronic diseases in the world, and for thousands of years, humanity has just had to accept a very grim reality. Once your tooth enamel is lost, it is gone forever. Think about the rest of your body. If you break a bone, your body knits it back together. If you cut your skin, it seals over with fresh tissue. Your body is a self-repairing machine. But dental enamel is different. It is the hardest substance in the human body. Harder than bone, harder than iron in some respects regarding scratch resistance, but it is biologically dead. Enamel has no cells. It has no blood supply. It has zero capacity for self-repair. This is because of how your teeth are formed. The cells that create enamel are called ameloblasts. These cells are incredible, microscopic architects. When your teeth are forming inside your gums, before they ever erupt, these ameloblasts are hard at work laying down the mineral structure of your enamel. But the moment the tooth erupts into your mouth, the ameloblasts die and are shed. They are gone. The tooth enters the harsh environment of your mouth, which is basically a chemical war zone of acid, bacteria, and crushing pressure, completely orphaned. It is a castle built once, with no masons left to repair the walls. For the last century, the standard of care for dealing with this problem has been remarkably primitive. If you get a cavity, we do not heal it. We drill out the rot, effectively excavating a hole, and then we fill that hole with inert material. We use amalgam, which is a mix of metals including mercury, or we use composite resins, which are plastics. This is a philosophy of repair and patch, not regenerate and heal. And these materials are not perfect. Amalgams require the dentist to remove healthy tooth structure just to get the filling to stick. Composites shrink over time. They leak. They get stained. They are foreign bodies glued into a biological whole. They do not mimic the intricate structure of natural enamel, and eventually they fail. This brings us to the breakthrough. Scientists have been searching for a way to regenerate enamel for decades. They looked at biomimetics, which is the field of abstracting good design from nature. They asked, if the ameloblast cells are gone, can we create a synthetic process that mimics what they used to do? See, the ameloblast does not just dump calcium on the tooth. It secretes a protein scaffold. Think of this scaffold like a blueprint or a net. It captures mineral ions from the environment and forces them to line up in a very specific way, creating the long, hard rods of hydroxyapatite that make up your enamel. Once the crystals are grown, the scaffold disappears, leaving behind the rock-hard mineral. For years, researchers tried to find a protein that could act as a surrogate scaffold. They tried using the original proteins, like amelogenin, but they are unstable and expensive. They tried synthetic DNA. But the answer, discovered by Dr. Sharif El-Sharkawi and his team at King's College London, was hiding in the trash bin of the barbershop. The answer was keratin. Keratin is the structural protein found in your hair, your nails, and your skin. It is incredibly tough. It is waterproof. It is resistant to chemicals. And critically, it is one of the most abundant biopolymers on Earth. We throw away millions of tons of hair and wool every year. The team hypothesized that keratin could function as the missing scaffold for enamel regeneration. Here is how the science, which they call keratin lithography, actually works. It is a fascinating process of turning waste into wealth. First, they extract the keratin from organic sources, like hair or wool. They break down the tough fibers into a liquid keratin protein. This liquid is then applied to the tooth surface. This could be done with a gel, a varnish, or even a toothpaste. Once that liquid keratin hits the tooth, something amazing happens. The proteins begin to self-assemble. They link up, forming a microscopic mesh or scaffold over the enamel. This is not just a passive net that sits there. It has a specific electromagnetic charge. It acts like a magnet. Your saliva is naturally full of calcium and phosphate ions. Usually these ions just float around aimlessly, but the keratin scaffold captures them. It grabs the calcium and phosphate and organizes them. It acts as a template. Because the ions are trapped in this keratin mesh, they cannot grow into random chaotic shapes. They are forced to grow into ordered aligned prisms. This is a process called epitaxial growth. That is a fancy materials science term, but it essentially means growing a new crystal layer directly on top of an old one, where the new layer perfectly matches the structure of the old one. The keratin allows the new mineral to grow directly out of the old mineral. When they tested this in the lab, they found that the keratin gel infiltrated the microscopic pores of early-stage cavities. It recruited minerals from saliva and grew a new layer that was not just a calcium deposit, it was highly organized. It formed structures called spherulites, clusters of crystals that fuse together to form a continuous hard shell. This new layer fuses seamlessly with the underlying native enamel. There is no glue line. There is no weak interface where bacteria can sneak in. The repair is chemically identical to the original tooth. But it gets even better. One of the biggest issues people have with enamel loss is sensitivity. This happens when the enamel wears down and exposes the dentin underneath. Dentin is porous. It has tiny tubes that lead directly to the nerve of the tooth. When those tubes are exposed, cold water or sweet food causes sharp pain. Current treatments just try to numb the nerve. But the keratin treatment actually seals those tubules. It grows a new mineral layer over them, physically blocking the pathway to the nerve and curing the sensitivity at the source. Now, you might be wondering, is this hair-based enamel actually strong? We tend to think of hair as soft and teeth as hard. But remember, the hair is just the scaffold. The final product is mineral. In comparative tests, the researchers found that the keratin mineralized enamel was significantly harder and more durable than conventional fillings. Standard composite fillings are plastic. They wear down. They release microplastics. This keratin-grown layer is essentially stone reinforced by a protein matrix. It has a graded structure, hard on the outside, slightly more elastic on the inside, which mimics the natural shock-absorbing properties of real teeth. This durability suggests that we could use this technology not just for fixing cavities, but for preventing them. Imagine a world where you do not wait for a hole to form. Instead, you use a keratin toothpaste or varnish every 6 months. You add a fresh, microscopic layer of sacrificial enamel to your teeth, constantly replenishing what daily life wears away. You are effectively resetting the age of your enamel. There is also a massive environmental angle here. We live in an age of resource scarcity. The dental industry is a huge contributor to pollution, using single-use plastics and synthetic resins that do not break down. Keratin lithography flips the script. It uses a biological waste product. Hair clippings that are usually burned or dumped in landfills become a high-value medical resource. It is a closed-loop system. Biological waste from hair is used to repair biological damage in teeth. The extraction process is water-based and solvent-free. It is biodegradable and biocompatible. So when will you see this in your bathroom? The researchers envision a two-tiered approach. First, the consumer tier. Within the next few years, we could see keratin-enhanced toothpastes on the shelves. Unlike current enamel repair toothpastes, which just deposit soft, unorganized calcium, these would provide the scaffold to rebuild enamel at a molecular level with every brush. Second is the professional tier. For visible white spots or early decay, a dentist could apply a concentrated keratin gel. No needles, no drilling. Just paint it on and let it heal. This would be revolutionary for pediatric dentistry. The trauma of the drill could be a thing of the past for the next generation. Of course, there are hurdles. The mouth is a chaotic environment. It has wildly fluctuating pH levels and enzymes that try to break down proteins. The researchers need to ensure the scaffold stays stable long enough to do its job. But keratin is naturally tough. That is why hair lasts so long. So they are optimistic. Clinical trials are the next step to prove long-term stability. This discovery is a triumph of lateral thinking. By connecting the keratin of the hair to the mineral of the tooth, scientists have unlocked a way to make our teeth potentially immortal. It is the dawn of regenerative dentistry. We are moving from a world where we replace biology with plastic, to a world where we use the body's own blueprints to heal itself. That wraps up this deep dive into the future of your smile. It turns out, the key to the hardest substance in your body was growing on top of your head all along. Thanks for listening to G Fun Facts Online.